Welcome, problem 11 here, and although not hard, a pretty cool problem. So to start, notice that we could write two integrals over this plus sign. And we do that by distributing this e to the minus x in the numerator to these guys, right? So the first integral will be 2 times e to the minus x divided by x cubed. And the second integral will be x times e to the minus x divided by x cubed. Yeah? Okay, so if you were just paying attention carefully, this is what I just said. So the first of the two integrals would be this, and the second of them would be this, because in the second integral, the numerator will have an x, and the denominator is x cubed, and we could reduce that to just x squared in the denominator, right? Okay, now, let's name this first integral a, and this second integral b, and let's work on a first. So, the naming, right? And then let's work on a. Notice if I take out this 2 and write it in front of the integral, a can be written as 2 times integral e to the minus x times, and I better write 1 over x cubed dx. And that's what I've written. Now, from here forward is integration by parts. So let's recall the integration by parts formula said that. And let's pick a u and a dv, right? Okay. So u would have to be e to the minus x, and dv is this here. So du is negative e to the minus x dx, right? And v, you could work out more carefully if you'd like, but it'd have to be this here, negative 1 over 2x squared. And you could arrive at that for v by writing dv as x to the negative 3 times dx, right? You could go from there. And but it's easy to see, right? Okay. Now, from here, we have 2 times integral u dv, and so that's going to be equal to 2 times this right-hand side, right? And so 2 times the right-hand side is going to go like this. What? Did I go too fast? Okay, let's slow down. So we know that where the 2 came from, and then it's uv, right? Like that's uv, and so u is e to the minus x, and v is this guy, so that explains why I have minus e to the minus x over 2x squared. This is uv, and then the minus sign from the integration by parts formula turned into a plus because v has a minus in front of it, and the next thing we have to write would have to be v in the integrand, right? And so the minus from here and the minus from there turned into a plus, right? But du has a minus, and so ultimately it came back to being a minus right there, right? Otherwise, the 1 over 2 is from v having a 2 in the denominator and a 1 in the numerator, and then it's v du, right? And so the rest of v would have to be 1 over x squared, which I have here, and then du is this negative sign, and then e to the minus x dx, right? Okay, so that explains everything, hopefully. And now the next thing we're going to do is distribute this 2 to this guy and this guy. When we do, this 2 is going to cancel that 2 there, and it's going to cancel that 2 also. So basically, we get rid of the half here and the half there, right? Okay, and so that'd mean that, let me slow that down since, that'd mean that we next write that a, the integral we're working on, this guy, is now equal to, in kind of cleaned up version, this, and then minus that. But wait, look here, look at this integral. Deja vu? It's exactly the same as this integral. So this here is b. So what we're going to write is a is equal to this here minus b. Now, if we go back and call the original problem we're working on, the original integral, if we call it c, then it looks like c is equal to a plus b. But a itself is this minus b, and therefore c is equal to this here plus b. And so when we write the plus b, the minus b from the solution to the a integral, this guy, and the b that was sitting there all alone chilling, they cancel, right? Like, so we get just this here, which is the solution to our integral. Yeah? Okay, cool. All right. I hope you enjoyed this. Keep watching. More to come.